All right, so I've started recording this and I'm just gonna like do a quick recap. So we're talking about methods, and we said it's a block of code that contains series of statements that can be executed. We talked about method signature, where a method might not return anything. In that case, you use void. A method might not return anything and have parameters as arguments. They are called arguments. You put in there. The cases whereby you might take multiple arguments like this and then still return a value. And there are cases whereby it doesn't take in anything and still return something. So, and then we talked about abstract class and an abstract method, and the fact that you must provide an override if you derive from an abstract class that has an abstract method. So if this class is not abstract, you won't even be able to do this anyways. So and then we talked about how they created an instance of this new class that derived from air and made use of all the methods that are in the motorcycle. They made use of everything except they make use of everything, all the methods that are air. So so if I didn't derive from, if I create another class entirely, and if I create another class entirely and I use that class, it doesn't derive from this place, then I won't have access to this add gas because this add gas is protected. So only derived classes can call it. But if I just create another class in my project, I can call this one because it's public. Public means everybody can call it, whether they derive from that class or they do not. So method parameters and argument, we talked about, okay, this is where I was just about to talk. So look at this, square of this number. So look at a method here called square. Square method takes in an int high. So when you define a method, you define the data type and the name of the argument. So in this case, we are calling it I. So high stores the input argument in a local variable, and then it just return input times input, meaning that it just multiplies by itself and returns an int. The int it returns there is a square of whatever value you put in here. So see the way they call square here. So you can call square with an int variable. See the way they call it. They define num a to be 4 and pass it in f, which makes sense. They defined num b to be 32 and pass it in air. You can also do this, just pass the literal directly without putting it in a variable. Instead of putting num a like this, you just put the value there, 12, and it will work. So that's also, you can do an evaluation within here, and that evaluation will just it will result to an hint. But the most important thing here is that it must be an integer. So whether you say 2 plus 2 plus 5 plus 7 plus 9 plus 15 inside this input, as far as everything sums up and becomes an integer, it's going to work. Does that make sense to us?
Yeah.
Okay, cool.
Yeah.
All right. So there is something called passing something by reference and passing something by value. So let me just look for an example to give us. I don't know if I've taken you through reference type and value type, so this might sound a bit complicated. Okay, let's talk about return values. So what's return value? These are data that you return to a caller. So when a method, take for example this integer method. So if I call this method and I get back this value, this is my return value. So if I'm building a calculator, for example, and that's it, we're going to build a calculator, in this program. So in a calculator, for example, this is a good function that I can use to do my square. So the person puts in the number on the calculator, maybe presses like 3, and then he pressed the square root. When he presses the square root, I'm going to call this guy. So when he presses equal to, whatever this guy returns to me is what I will display on that screen. Do we understand what I mean by that?
Yeah.
Yeah. So, so you can have add method, you can have multiply, you can have subtract. And, when you're building out your calculator, that's how you're going to have, method for all these implementation, square root, logarithm, everything. So, and at the end of the day, you now put everything together and then provide an interface for the what's it called, for the user to input his parameter and to see your result. But in the back end, this is all the kind of logic you'll be building. So when we say caller, the caller is within that class where the method was used. So when you return this value, the caller will do whatever they want to do with it. They might want to display it, they might want to store it, they might want to do anything with it. Okay, so look at this. For example, this is a simple math class. Add two numbers, and I'm passing integer 1, integer 2, and there's a return statement that returns the sum. Hope we're familiar with this syntax, return. Have we done anything on it? Hello, we haven't.
Hello.
Hello, I said we haven't, right? We haven't done anything on return.
I've used it, but I'm not sure we used it in the class.
Okay, we probably haven't. So when you say return is the place where your function will end or terminate. So when you say you should return, you are saying stop whatever you are doing, and that's the end of what I want. So you can't write anything after this return. You can't write anything. So look at this. Add two numbers, takes in the two numbers. It now returns this plus this, and that's why it's an int. If it's going to return a double, that means we have to convert whatever the result of, because if you had an int and int, it would be an int. You have to convert it to double before you return it. So return is the end of your function. It tells that what it does is whoever called this function, return back to them. So you can return a value. If the method is void, then you won't need a return statement. Remember we have methods that have void. You remember which one was that? This, for example. If you call this guy within the definition of hard gas, you don't need a return statement because it returns, because it's void. So when you look at that in the same way, square a number, add a number. So return will mark the end of your function. Does that make sense to us? Can I continue? Or we should go and write some code? Should we write some code for this, or it's clear enough? Write code, or we should move on? Who wants to write code?
I think it's clear.
Maureen?
Yeah, it's clear for me too.
Okay. Olatunde and
It's clear. Yeah.
okay. I mean, you can practice this. This is a very, how many, 4 lines of code, but it will just help you to see what I'm talking about. For instance, if you put an integer here and you don't have the return keyword, it's going to give you an error and says you said it's going to return an integer, but I can't see any return. You didn't put any return anywhere. And at the same time, if you say it's going to return string and you are returning int, it's going to also complain. So that's one good thing about static programming languages. Statically typed programming languages, the type are defined. So you can't just, say you return a boolean and then you are returning a string. It's not going, the compiler will not allow you to go, because that kind of thing can lead to execution when your software is running. So you finish the software, you've sent it to the person that will use it, and this kind of thing is happening. So it's going to cause a lot of failures in your code. So compilers will pick those things for you. And I also want to read about compilers and interpreters, but that's not right away. So, but you can note it down: compiler, interpreters. So compiler, we take that error for you at compile time. Compile time is when it's putting your code together, when it's converting your code to the runtime that it's going to run on. That's when it's compiling. That's when you build in Visual Studio. You see something called build. So that's compiling. So that kind of error will pop up at that point. So pretty much, and then when you want to call this add two numbers, see the way they called it, result is obj dot add two numbers. And then, you just get the result out and then you write it out. Yeah, so using a local variable, in this case, result, to store your value is optional. Exactly. So you can just say return. You can, in fact, you can return this. You can just put a return this air without putting it inside result and then writing out the result. You can actually put it inside the right line statement and it's going to work. So it's optional. Are we together? Hello.
Yeah, we're here.
Yeah. I'm skipping arrays for now because we haven't done arrays, but some of you would have come across arrays. Right? We talked about lists last week. List and array are very similar. They take in data in the same way. You can index them in the same way, but lists are much smarter, more dynamic than array. Arrays are fixed. So, and there's what we call single dimensional array, two-dimensional array. So, I mean, I haven't talked about it, so I don't want to, so that I don't get you, alarmed. Yeah, there's something called asynchronous. I don't know if you've ever heard about it before. When you say something is asynchronous. Now, this is one of the terms that, we used to make a lot of joke about. Especially when, developers are joking. So asynchronous means that something is running. The easiest way I can explain it to you right now is like something is running simultaneously. So if I'm supposed to do something, if I have if I have a car and I need to go to the next city, and the next city is like 5 hours, and my car can only take 5 people, and we have 20 people that are going. Now, because my car can only take 5 people, I have to take the first 5, right? I have to go 4 times. Is that correct? I have to go 4 times.
Yeah.
Now, if I'm running asynchronously, it means I have 4 cars. So instead of going and coming back 4 times, I'll go asynchronously in the real sense of it will mean that asynchronously in real sense of it will mean that I can drive 4 cars at a time. Yeah, that's the real sense of it. So it's the same the same person, but instead of driving 1 car, I can actually drive 4 at a time. So I'll just put everybody 5 in all the 4 cars and drive once. That's asynchronous. So it means that, I'm able to run something in parallel. I'm able to run things in parallel compared to do one before I finish the other. So I don't know, does that paint like a picture in your mind? So in C#, we call it async. So when you mark something asynchronous, what you are saying is that this guy can run simultaneously. It can run like a lot of instances at the same time. So look at this class. They called it do something async. So whatever I'm doing, it means I can do it asynchronously. It means I can do it asynchronously, and that means that I don't have to wait to finish one before I start the other. Are we together? It's like I've lost everybody.
Not really. I've come across that term before. When we are doing Jordan salary process.
Mm-hmm.
So the salary process needed to validate customers' account, the employee's account number. It needs to send it to NIP to validate whether that account number is correct. But because it's quite a lot, so they had to use the asynchronous process. So while you are still going on to process the salary, impute total amounts, debit account number, you would have uploaded that Excel file, which on the background will be asynchronously validating that detail, those things you've the employee information.
Exactly.
So you can carry on with your
You can carry on with your process without waiting for one to finish.
without waiting for this validation.
Makes sense.
So at the end of the day, to process, then the ones that didn't process, will not throw it back to you with the error. But it also doesn't stop you from going on to the rest part of the form.
Makes sense. Makes sense. And that's a good use of asynchronous. So, and that experience also comes into play because you've seen it used, you've used it before. So when they say something is asynchronous, that's what it means. I hope Maureen understands this, and Han and Olatunde. Do you guys?
No, I don't understand it actually.
You don't?
I understand the theoretical part. But
Yeah. I mean, of course. I mean, I'm not after you be able to understand this snippet of code right now. I'm just trying to pass on the message of asynchronous. You will use it, you will understand it. So, but the idea is that it can do something without waiting for the other one to finish. Yeah. So if you can copy this code and run it, so you see task 1, task 2. So the way asynchronous work in .NET is going to create what they call task within itself. So those tasks will now be the one to be carrying out the operation. So, and because it can generate like 1 million tasks at the same time, it makes it easier. So it can just assign one task to do one, another task to do one, another task to do one, another task to do one. Do you understand? So, and then it will now at the end of the day when it's done, it can now gather all the task and say, guys, how far have you guys gone? So that way, when I send 100 things, I don't have to. For instance, when I build APIs, all my APIs are asynchronous. I build it in by default. When I was still in Access Bank, there was something I built the USSD. That was like it was my last project before I left. And these are USSD that millions of people are using. And I can't be waiting for somebody to finish before another person. Do you understand what I'm saying? So somebody is dialing USSD code. So do you want to tell me that I should wait for him to finish before another person will be able to process it? Yeah. So exactly. So you have to build asynchronous into it by default, so that as somebody's request is coming in, is going on his own, another person's request is coming, everybody is processing their request. There is no waiting for anybody, right? That's one way to look at it. Another way is that the same person can be doing two different things, maybe like on your mobile app. So, or let's say, I mean, just think of things that need to run in parallel for now. And that's how I want you to understand asynchronous operations. So you will have methods that will be able to run async. When you see something like this, do something. This is the name of the method. They now put async in front. They are telling you that this method is asynchronous.
Okay.
Yeah. And most of the time, they return a task. Right? I told you task is the element of work that system assigns and say, go and do this work, go and do this work. So most of the time, asynchronous operation will return a task. It might not be a task directly, it might be a task of int. It might be a task of string. Look at something like this. A task of int, a task of string, meaning that is a task, but this is what is carrying. And this could be an object. It might not be integer. It might be a custom object like mentor, like anything, student, whatever. So, I mean, that's like, that's my summary for you right now. See, what I'm trying to do is look at all this documentation. Look at what you need to learn. Are you with me? See, this is getting started. These are tutorials. There's a lot. So this is your friend. This page, this document I'm opening, this documentation. All of us, even experienced programmer and my seniors and everybody come here to come and reject something one time or the other. Do you understand? So this is somewhere that you will be familiar with, coming to come and check one thing or the other. And the documentations are very good. So that's why I'm interested in teaching you how to read it. so that when you know how to read it, when you are confused with something, you can always like come back and check. 1 minute, my battery is low for my headphone. Let me grab. Yeah. Correct. So async method, those are async, and you're going to need async a lot of times. When you're writing code, especially when you start building, very heavy systems, when you start building for scale. They call it building for scale. And I learned a lot, when I was in Access Bank, because there's a huge customer base, and you want to serve everybody's request and all that. So expression body definition, let me see if this is useful for us. Iterators, yield statement. Okay, so really we don't have much around here. There are things you come back and look at yourself sometimes when you need it. So I mean, I hope I made a bit of progress on methods. So you shouldn't be, some things wouldn't be strange to you any longer, like they have. What was the next thing that I sent to you over the week? The next thing I sent was Git, right? Git, and I said everybody should create GitHub account. I saw Hans' GitHub account. I saw Maureen's GitHub account. I saw Ben's GitHub account. I didn't see Olatunde's own.
I already have one,
okay.
But I didn't.
You didn't push the code there?
I'll do that after this call. Yeah.
Do you have some code there already?
Yeah.
Okay. All right. That's fine. So do it. I mean, the idea, this is not even any, for people that are new to GitHub, I mean, I wanted them to push the code so that they understand how it works. And I'm going to do a very brief explanation on it. So if you can see my screen, I'm going to just, maybe I can, all right, so. Okay, so on the command line, when I do Git, and I want to explain what Git is for, because you're going to need it. There's no way you will not need it, and you have to know it. So, can someone tell me in a minute what Git is used for, at least from what you've?
Say.
Who wants to Yeah, go ahead.
So I think the version control tool that helps a lot with collaboration. So the way it works is it keeps snapshots of files so that you can track files basically. So it helps like a whole lot in collaboration. It's a version control manager, I think. Yeah.
You are very correct. I mean, you don't have to think because that is it.
I think it is. Okay, so Git is used to store different versions of your code. So let's say you built to a certain point, then you want to like commit it and push it to Git. So you are building later on, maybe you made a mistake that scattered the whole code and you don't really know how to go back. So you can go to Git and retrieve your code and start building from the last good point onward.
Yeah. That's also a very good point. Yeah, like you said, it's for version control. And when you say version control, you just want to keep different versions of your project or your code at any time. And the funny thing is, it's not only what's it called? It's not only code you can use Git for. You can use Git for documents as well, and you can use Git for a lot of things. So, but code is like the binary thing that that's very popular that people use it for. So, yeah, I mean, like you said, it can help you to store the version so that you can always go back. Another thing it can help you do for you is to align code together. And you have So take, for example, there are 5 developers working on the same project, and all of you are working on different parts of the same project. So at some point, this one has written his code down, as you need to put everything together. Of course, you won't be doing copy and pasting. That will be hell if you have to copy and paste, code from different places. So then I'll copy my own, send it to you. You will add your own to it, then copy and send it to somebody else. So that's what Git came to solve. So, and then it's very good in that. So I will just explain a couple of things. So when you do a Git clone, everybody knows how to clone a repository. Now, have you cloned a repository before? Have we?
Me, no.
No. Okay. So Git clone is, for instance, if I go to GitHub, GitHub is where people store their code. It's open source. It's free of charge. GitHub, I just want to pick just any kind of code, and then I'm just going to clone it. So cloning is like you are pulling a version of somebody's code. You're pulling a version of somebody's code. Okay. Come on now. Sorry, excuse me. So so this is code from 4 years ago that I wrote. You remember 2016? Okay. So now I can give you this code. It's free. So if you see a code that you like and you need, this is not C#, this is Go. There's a programming language called Golang. This is Go. So this is not C#. Let me see if I have C# code so that will be more useful for you right now. New REST API. So on GitHub, repositories are different projects, that people have written, and then so we can go to, okay, this online connect. I don't know what it is. Okay, so I mean, I'm just going to use any repository. It really doesn't matter. What I want to teach you has nothing to do with repository. So this is a React website, and then I can look at this URL now and copy it. Are you with me, Maureen? So if you do Git,
Yes, I am.
so you go to a repository in your system. So let's say I want to just kind of go to the desktop, cd user cdcl, right? And then I'm just going to go to desktop. Now I'm on my desktop and I'm saying git clone, and then I put the URL that I want to clone. When I press enter, it goes to this repository. Sorry, I need to turn on my proxy. This is an office workstation, so it goes through proxy. Yours will just work straight up. You won't need to go through any proxy.
Is it possible to have created a folder on your desktop and then run the folder with Git and then put in the code?
If you want to, yes, you can. But if you don't, it's going to create this website for me. It's going to create this folder for me automatically.
Hello?
Hello, can you hear me? Can you hear me? Hello? Hello, Maureen, can you hear me? Am I not audible again? For some reason, I couldn't hear again. I don't know what happened.
You went off and you came back online.
Okay. I don't even know what happened. Maybe it's the network. I don't know. So I was trying to. So I just did a clone. I mean, I'm trying to do a clone rather. So
You're no longer sharing your screen.
Oh, okay. Sorry.
Oh, I can't see. And then I wanted to ask, is it possible to have created, or instead of finding the root folder through JIT, is it possible to have created a folder on your desktop and then run the folder with JIT and
Yeah,
then put the clone?
yeah, you can.
Okay.
You can create one. You just need to understand your folder structure. So if I do git clone this URL, for example,
Yeah.
git, you know, I'm on the desktop. I ran this command from the desktop.
Okay.
So git will go to the desktop and then create this folder for me.
Yeah, but if you could have gone to your desktop directly and then created the folder and then ran JIT on the folder, right?
Yeah, sure. I can do that as well.
Okay.
I can do that as well. So I mean, depending on, but when you run git clone, it's going to put that your code inside the name of the folder. The name of the folder will be the name of the repository online. So it means if I go and create React website folder, it's going to create another React website folder for me. Do you understand? So it will not be.
Wait, no. If you don't do it the way you just did it, and you went to your desktop to create the React folder thing,
Website.
and then you React website, and then you did your right click and ran it with JIT. You're saying it would, even when you just put in the code, the JIT clone and the URL, it will still create another folder. Is that what you mean?
Yeah, it will, because this clone. Look at this clone URL. When you have a URL, this last repository part is a folder. So it's going to put this folder.
So will it create a folder inside the folder you created?
Yes, it will.
Okay.
It will create. It will drop the repository inside that folder. I mean, it doesn't know the name of the folder I created. It doesn't care where the location is. His own is that I said you should clone this repository, and then it's going to clone it.
Okay.
Do you understand? So that's why when you don't need to already have a folder on ground to clone a project, because it's going to create a folder for you anyways. Or else you're going to have folder.
I think I was just avoiding writing the path to the desktop. Maybe that's what I thought was easier. Okay.
Okay. Don't. Yeah, if you need a folder, you know, you can do mkdir, that's make directory. I sent you one link like that. If you remember to go through it, you know, the things that can make your CD is change directory, mkdir is make directory. This will create a folder for you, you know. And you can just do all those things from the command line. I mean, those things help your productivity so that you are fast. But you know, it's just a matter of style, but it's command line are very helpful. So I mean, because I'm going through a proxy, my official proxy, so it's not connecting to my websites. I have a lot of settings in the background. My proxy is on. So, but if you do this locally on your system, it's going to work like on the internet, straight up. So this didn't work for me because, you know, I have a proxy in between. And, you know, if you're working in a corporate environment, they always want you to go through proxy. They want your internet to go through proxy so that for protection. So they can see everything going to the internet. They can see everything coming from the internet. So that's why this is this. But this Git clone will work straight up. So, but in that case, you know, I will just go to somewhere where I already have a repository, and then I'll show you the things I would have done. Okay, so this is a code. If you do git status, it will tell you, you know, look for example now. I'm on a branch. This is the name of the branch that this code is on. Your branch is up to date with this. Nothing to commit. The working tree is clean. Let me explain what all this means. So when you create a repository, you're going to have branches. Branches are like tree. I mean, the idea is that there's a tree. That tree is your source code. So there are different branches of that tree. So Ben can be working on branch 1, Maureen is working on branch 2, but everything is coming from the same tree. So Maureen can have changes on branch 1, Ben can have changes on branch 2. So at the end of the day, we want to merge all the changes together and let them be in the same tree. Does that make much sense to us?
Yeah.
So I think somebody else should share screen, and then let's use their command line, and then we can make a branch. We can create a branch out of our code, and then make changes to that branch. So who wants to like volunteer to do that? Who? You want me to pick somebody? Ben?
It's here.
Okay.
Okay, let me share screen.
Share screen. I've stopped my share. Now, Git is something that you must know, you must learn, because as you're writing code, you need to keep them somewhere and all that.
Can you see my screen?
Yeah, we can see your Zoom. So you might want to, yeah, so open a, go to the folder where your code is currently stored. You've already pushed, so it's fine. Let's just go to the folder where this code is on your local system.
Okay. This where the code is on my local system.
Okay. So highlight this, click on that path and type CMD. Yeah, type CMD. Just type CMD. On that, no, just type CMD on that place.
CMD. Okay.
Yeah, because some people might not be using the Git bash. Enter. Okay. So I wanted us to use this so that for people that are not using the Git bash is the same thing. If you've installed Git correctly on your Windows, this thing will be able to do the same thing the Git bash is doing. So type Git status. So Git status will tell us the status of this repository. So this repository is currently on branch master, and the branch is up to date, meaning that there's something called origin, there's something called local. So origin is the GitHub where your code is on the internet. Now, origin in your case might not be internet in your office. It might be on a local machine somewhere. It might be Bucket, Bitbucket. It might be Azure DevOps. Origin might be anywhere, but it's the same concept. So now I'd like you to type git branch -a. Yep. So this will list all the branches that we have in this project. We have a master branch, which is local. That's the color green one. And then we have a master branch, which is remote. Are you people following me?
Yeah.
Okay. If it's not clear, please let me know. I know some of you have experience in this before, so that makes it very good. So there is a remote, there's a local. So right now, that star shows that this version of code is on master branch. So you can create git branch